This topic is called rationalizing radicals. I think of it as like the second rule or the second property of square roots. And basically, to sum it up, hold on, let me get that phone. All right, sorry about that. Like I was saying, rationalizing radicals, to put in layman's terms, you have to do it because it's quote-unquote illegal to leave a square root in the bottom of a fraction. So what is illegal? This is illegal. You can't have this in the bottom of a fraction. That's a big no-no. Math police get involved the whole bit. It's pretty nasty. Similarly, the same rule, but it can look a little bit different. Having this is also illegal. The reason being that this doesn't look the same is because we can actually rewrite it like this. And once again, we have that pesky radical in the bottom of a fraction. Math books can present it with all these big words, rationalizing radicals, denominators, numerators, all that stuff's good. We know the denominator is the bottom, the numerator is the top. Rationalizing radicals, to put it simply, is don't leave, maybe write this in your notes, don't leave a radical in the bottom of a fraction. You know, you can do it as part of a step in a process, but you don't want to leave it that way as a final answer. And anything that you take, if you're like taking the MCAS or the SATs or anything like that, any of your multiple choice questions aren't going to have the radicals in the bottoms for an answer. So you better know how to kick them out. And that's what this video is about. It's really not that hard. I think what I'll do is I'll give you guys a couple of examples, show you what I call a trick, and then towards the end, if you're interested, I'll show you where the trick comes from. I'm torn about whether showing that first or last, but I think I'll just show that part last, and you'll kind of see where the trick comes from. Alright, so here we go. I'm going to scroll this guy up a little bit. No, I don't want to exit out, I just want to scroll it. There we go. So let's say that we walk into the room in math class, and oh my gosh, there it is. You realize that the math police are going to have to get involved. It's going to turn into a nasty, nasty thing. So you get into action. And here's what you're going to do. To get rid of a radical that's in the bottom of a fraction, you swing it up so that it's sitting up top. So it looks like this. This is the new top. And then you have the power for the bottom to basically erase the radical and just rewrite the bottom like that. So as long as you bring the radical up top, you can erase the radical on the bottom. And that is it. You are done. Not such a big deal, huh? Let's try another one. What if we have 10 over the square root of 9? Again, you walk into the room, you see that on the board, you go into fight or flight mode, you're a fighter, so immediately you grab this up, you bring it up, 10 square root of 9 over 9, but then you're like, wait, I know radicals. Why would we leave that out? You wouldn't, because what is the square root of 9? The square root of 9 is 3. So we need to multiply the 10 times the 3, and now we end up with this awesome number. There's not even a radical in it, so we can just like relax and not have to worry about did we follow all the rules of radicals, because we are set. Let's try another one. Let's see. Let's say that we have 11 over the square root of, I don't know, let's say 10. Again, the trick, swing that guy up top, so when we rewrite it, does it look messy? Heck yeah. On the bottom, since we swung the square root of 10 up top, we can now erase the radical on the bottom. That's the most disgusting looking answer, and we're done. There's nothing else we can do. I know I keep saying and there's nothing else we can do. So let's have an example where there is something else that we can do. So let's say that we have, 2 over square root of 6. Same deal, nothing is different. We see it, we realize we need to fight our way out because this isn't okay. We swing the square root of 6 up top, erase the radical on the bottom, and ta-da, we're almost done. Now, most of you guys have some fraction intuition here, and you're like, geez, I really want to cancel something out. I feel like something could reduce. And the rule is you can reduce numbers that are under the radical with numbers that are under a radical. And you can reduce numbers outside of a radical with numbers outside of a radical. So if you look, we have this 2 and this 6. They're both not under a radical, so that means they're out. They can reduce if possible. In our previous example up here, the 11 and the 10, they have no common factors except 1. So we're not reducing that, we're just leaving it alone. the example that we're doing now, the 2 and the 6 has a common factor of 2. So when we reduce it, we end up with this. And another way to write it, if you want, is to lose the 1. Who cares if there's a 1 in front of the radical 6? It's all A-okay. Alright, so sometimes there is one little extra step to do. Let's try another one. Move this guy out of the way. Let's see if I can unbusy that a little bit. Now let's say that we have 12 over the square root of 3. Same deal, we're swinging that square root of 3 up top. That gives us the power to erase the radical on the bottom. Bam, we have two numbers that are not under radical. They can reduce, and our final answer becomes this. I mean, you can also do the 4 square roots of 3 over 1 if you want. It's not wrong. So either way you want to write it is completely good. Another example for rationalizing radicals is if we have a little different number on the top. Let's say that this time we have the square root of 5 over the square root of 2. Don't panic, it looks a little different, but that's okay. We're going to follow the same steps. We're going to swing the bottom guy up. So this is what we're going to do. On the bottom, now that we have the square root of 2 swung up, we can erase the radical on the bottom. So there is one more thing to do. We can multiply numbers under a radical with numbers under a radical. Since the 5 and the 2 are both hiding under radicals, they're okay to multiply. 5 times 2 gives us 10, and we're all set now. It's a little tempting to reduce that 2 into the 10, but what's the rule? The 10's under radical, he cannot reduce with a number outside the radical. So you have to stop and just say, nope, you guys just have to stay just the way you are. Let's try another one. Alright, let's say that we have the square root of 15 over the square root of 3. Same deal that we have been doing. Swing the square root of 3 up. And some of you guys are going to be like, how do I really need to write this step out? Not necessarily. If you get really good at rationalizing and you're getting them all right, it's a-okay to kind of skip that step. This, I think of it, this is your brain step. This is what your brain needs to be thinking about and doing. And then you can rewrite it out. So square root of 15 times the square root of 3. The 3 and the 15 are both underneath the radical. 15 times 3 is 45. And then I have a 3 on the bottom. Alright, so this feels like I'm done because I have a 3 and I have a 45. The 45 is under the radical, but the 3 isn't. They can't reduce. However, what do we know about the square root of 45? The square root of 45 has a perfect square hiding underneath it. 9 times 5 gives us 45, and there is the culprit. So what I'm going to do is I'm going to rewrite the square root of the square root of 45 as the square root of 9 times the square root of 5 over 3. And again, this is also kind of a brain step. Do you need to show this part out? Not necessarily if you're good with them and you know that you're going to get it right. If you're kind of new to it, I would suggest writing that step out because it slows you down, pinpoints your details. So, what is the square root of 9? Square root of 9 is simply 3. So we take out the square root of 9 and put in a 3. And now, yep, once again we feel like we're almost done, but this is just screaming at you, isn't it? 3 over 3, that can reduce. So our final answer for that whole thing is the square root of 5. There's really nothing new here. It feels like there were a lot of steps, but we're just doing what we do. When we have fractions, we try to reduce. When we have radicals, we try to simplify. So we're applying those properties to these things as we go through. And it just happened that in this example, we had simplifying and reducing to do. Let's try one more example, and you might, on this one, you might want to try it, writing it down and then hitting pause and see if you can swing it out by yourself. So let's say that we have I don't know what's a good number. How about square root of 10? And we're going to do square root of, I don't know, let's try 8. All right, no panic here. We're swinging that square root of 8 up there. There's my brain step. The bottom becomes a plain old 8. Square root of 10 times the square root of 8. They're both inside numbers. That's 80. So I'm thinking about factors of 80. 8 and 10, 4 and 20. That's interesting because of the 4. I just want to see how many times 5 goes into it. 5 goes into 80 once, 3, 16. Ah, yes, yes. That's the one I want. So I'm going to rewrite square root of 80 as a 16 and a 5. The square root of 16 turns into 4. So we end up with 4 square roots of 5 over 8. Final step, reduce these two. So we get square root of 5 over 2, and we're all set. That's really the gist of rationalizing radicals. I am going to show one more example. If you feel like you've got it, that's great. If you want some more practice, that's great. But after this final example, I explain to you where the trick comes from. So just bear with me. Okay, let's say this time we have an example where we actually have a fraction under the, well, we have a fraction under the radical. The first step you want to do is put it into, give them each a house, I guess. This looks a little bit more familiar. We can breathe. It's like, okay, I get this now. Apply, apply the trick. So now we have square root of 3 over times square root of 5 over 5. 3 times 5 gives us 15. The only factors of 15 is 3 and 5. They're not perfect squares, so we can't simplify it. These guys can't reduce, so we are done. All right, let me explain where this quote-unquote trick comes from. It's really not a trick. It's really something that has a lot of logic to it. It's just not super intuitive. Let's go back to an example. Let's say we have 2 over square roots of 3. What we want to do is we need to remove the radical. And we're going to take this fraction and we're going to multiply it by 1. However, we're going to disguise the 1 as square root of 3 over itself. Anything over itself is 1. Now let's see what happens. When we multiply fractions, we go tops times tops and bottoms times bottoms. So our top is going to be 2 times the square root of 3. On the bottom, we have the square root of 3 times the square root of 3. Well, we can multiply those, right? So the square root of 3 times the square root of 3 gives us the square root of 9. And now you're like, wait a minute. Square root of 9 just turns into 3. So when we simplify that, we have 2 square roots of 3 over 3. And if you do this process enough times, kind of what I call the long way out, you'll see that it's just as easy to teach it as swing this sucker up top, erase your radical on the bottom, and you're done. Because you end up with the same exact answer. Swing the radical up top, erase the radical on the bottom, and you're done. So that's where the trick comes from. It's just a sneaky way of multiplying by 1 so that the radical, the number under the radical becomes a perfect square, so there is no longer a radical. All right, thank you.